Arithmetic sequence, it says the next number is the previous number plus d. That's how they write the equation. What does that mean?
Is the previous number plus the difference.
Exactly. So I could have something like this: 1, 3, 5, 7, 9. You get the idea. Each number is what? The previous number plus what? 2. You're adding a 2. So here, if I want to get the next number, let's say the one after this, I take the previous one, which is the 9. I'll add to it the difference. The difference in this example is plus 2. So each number is the one before it plus 2 added to it. So if I say, what's the next number? You go what? 11. What's the next number? 13. So we have, this is the first number, the second number, the third number, the fourth number, the fifth number, the sixth, the seventh number. What is the 50th number? You got to keep writing, huh? This is only the 7th number. I want the 50th. You go, well, I got you. The 50th number is equal to the 49th number plus 2. I said, good. What's the 49th number? Oh, I don't know. I gotta go find it. So is there a way you can jump to that number without having to list them all?
Gotta be.
It has to be.
50 times 2? Or?
So the answer to that is yes, we can jump to that number. And to find that number, what'd you say? Any number you want to find, you take what? The first number plus n minus 1 times d. So I ask you for the 50th number here, right? N is 50. It says take the first number, which is what? 1, add to it 50 minus 1 times the 2. D is 2. 1 plus 49 times 2. What's 49 times 2? 98. Plus the 1, the 50th number is 99. Does it really work? Well, let's see. This is the first number, second number, third number, fourth number, fifth number, sixth number, seventh number. Let's find the 8th number. We know it's going to be what? Isn't it 15? Let's see if this actually gives me 15. It's the first number plus n minus 1 times d. My first number is 1. N minus 1. What's n here? 8. 8 minus 1 times 2.
14.
That's 14. What's 1 plus 14? Is the next number 15? Yep. So this will allow me to jump and find any number. So arithmetic sequence, the next number is always either addition or subtraction of the one before it. Not multiplication. It's either addition or subtractions. So I'll give you another one. I could have one that looks like this. 8, 5, 2, negative 1, and so forth. You notice now that the next number is what? The one before it. Add to it or subtract 3. Or add the negative 3 if you want to use addition. You can say minus 3, or you can say it's the next number or the previous one plus a negative 3. You adding a negative 3 to it to get the next number and the next number. So the D here is going to be what? Negative 3. First number, second number, third number, fourth number. Let's find the 5th number. It should be what? Negative 4? 1, 2, 3, 4. Let's find the 5th. Let's see if it's negative 4. It's the first number plus what? N minus 1 times D. What's the first number? 8. 5 minus 1 times what? Negative 3. 4 times the negative 3, which is what? Negative 12. What's 8 minus 12? Is it negative 4? Wasn't that the next number, negative 4, if I just continue writing them?
Yes.
What is the 15th number without writing them? It's going to be A1 plus 15 minus 1 times D. A1 is the first number, 8 plus 14 times the negative 3. 8.
So it's negative 34.
Negative 34. Let's say I want to add them. I want to see what the sum is equal to. I'll take another one. 3, 7, 11. What am I adding each time? What is it? 4, yes. And so forth. This is the first number. What is it? This is your first number right here. This is the second number, the third number, the fourth number, the fifth number, the sixth number. If I want to add them, what's the sum of the first 6 numbers? The sum, as for the sum. What do? You take your calculator, 3 plus 7 plus 11 plus 15 plus 19 plus 23. What is the answer equal to? Equals. I got 78. What about if that list is really big? Is there a way to find the sum without having to push all these buttons? And the answer is yes again. How do we find the sum? Here's the equation for that. To find the sum of n numbers, it's n divided by 2 times the first number plus the nth number. So n here is what? And this, let's do it for these 6 numbers. What's the sum of the first 6 numbers to see if it's working? If I get a 78, I know it's working.
So all the n's will be 6's?
N is 6, yes. So 6 over 2. A1. A1 is the first number, which is what? 3 plus A6. A6 is which one? 23. 6 over 2 is what? 3. What's 3 plus 23? 26. Let's do the math. 3 times 6, 18, 8 carry 1. 3 times 2 is 6 and 1, 7. Is that the same answer?
Yes.
Yep. The same example. I'll give you a few examples in a minute there. Actually, I'll get to example. Well, I'll stay with this for now. 3, 7, same one, 11, 15, 19, 23. Can you tell me the sum of the first 50 numbers? Now the equation says, oh, that's easy. N over 2 times what? A1 plus A50. What's N equal to in this example? 50, right? So we got a little problem. So this N is 50. Let me put a 50 here. So it's 50 over 2 times A1 plus A50. Well, we don't know what A50. I only know the first 6 numbers.
Don't we have to do that other?
So yes, I got to find the A50 first, which is what? A1 plus N minus 1 times D. It's 3 plus 50 minus 1 times D, we said what? Which is 4? 50, not 5. So 3 plus 49 times 4. The 50th number is going to be 199. So you got to find that first. Now can we find the S50? The sum of the first 50 numbers. It's 50 over 2. A1, the first number is 3. The 50th number is 199. 25 times what? 3 plus 199, which is what? Is that a 202? 202 times 25, 50. That's the sum of the first set of numbers. 50 numbers. It's almost Christmas time. You drive by Christmas tree farm, and what do you notice? That on the first row, these are Christmas trees here. You're driving by, you counted, you saw 21 trees. And you ask the farmer, say, how'd you plant these? Well, I decided to make each row 2 more. So the next row has what? How many trees? 23. The next one has how many trees? 25, and so forth. You go, how many trees do you have here? Oh, I don't know, I never counted them. Well, all you got to do is count how many rows does the farmer have. How many of these rows?
3.
So let's say, no, not just these, because there's more, I just didn't put them there. So let's say there are 17 rows here. Altogether, 17. Can we figure out how many trees that farmer has?
Yes.
Sure. So first, how many trees in the last row? In row 17. How many trees? That will be A1 plus N minus 1 times D. The first row has what? 21 trees. N is 17, take away 1. And each row has how many extra trees? 2. 2 times, what, that's 16? That's a 32. 32 plus 21 is what? 53. So the last row actually has 53 trees. So what's the sum of the trees? Oh, no, I'm sorry, not 10. What is it? 17. Has 17 rows. It's going to be 17 over 2 times row 1, which is 21, plus row 17, which is what? 53. (21) plus 53 equals 74. So 17 over 2 times the 74. Multiplied by 17, divided by 2. That farmer has 629 Christmas trees planted.
About 300.
At about $30 a tree. 30. There's no more 30s.
I'm saying this.
629. Let's say 50% of them are sold. Roughly 314 trees, 315 times $50 a tree, $15,750. Not bad. Month of sale. They planted for 3-4 years before they get to more than 3-4 years to get mature.
Well, it's probably like 10,000.
So that's what arithmetic sequence. Each number is like 3 plus or minus some number more than or less than the one before it. We call these arithmetic sequences. That's that section. That's it.